Do you know that the gravity of the sun is only about 46% that of the moon? Even though the sun is 27 million times more massive than moon, it is also 390 times farther away from the earth than the moon. If the sun is halfway closer to the earth, then the tidal forces on the earth will be almost equal to that of a moon. But how do you explain how tide happens to a non-science students or to a surveyor whose job is simply to go out on a boat, take some depth, come back, take the tide out and plot the soundings on a chart? There, you see, for a everyday Joe like you and me, tide is what makes the water rise and fall, and we need to compensate for it if we are to make a bathymetry chart. Let's try to visualize. We think that the earth and moon interacts this way, but it is not. We think that moon revolves around the center of the earth. But in fact, moon and earth rotates and revolves around a common center point which is about 4670 kilometers away from the center of the earth, and it is called Barycenter. To add a little bit complexity, let's put the moon's orbit about 5 degree inclined. Yes, it is about 5.14 degree inclined than the plane on which the earth revolves around the sun. So you see, earth is wobbling as it is also rotating, and same kind of thing happens with moon too. Now we all know that gravity of the earth is keeping us and all the water firmly on the ground, and this gravity is the vertical force acting perpendicular to the earth's surface inside towards the earth. Gravity is almost similar at everywhere on earth. On the other hand, the rotation of earth creates a powerful centrifugal force. Now this centrifugal force is the horizontal force and acts away and tangent to the earth's surface. Now this centrifugal force is not similar everywhere. At the pole there is almost no centrifugal force, and at the equator the centrifugal force is highest. Rotational speed of earth at equator is about 1600 km per hour, and at the north and south pole it is almost zero. That centrifugal force overcomes the gravitational force at the equatorial region, and it is the reason the earth bulges out by about 22 km at the equator. Now these two forces combine and create something known as tractive or drawing component of force, which is the actual mechanism for producing the tides. At any point on Earth's surface, the tidal force produced by the moon's gravitational attraction acts with these two components of forces. There is an active tendency for water to be drawn from other points on the Earth's surface towards the sublunar point and its antipodal point, and to be heaved at these 2 points in 2 tidal bulges. Within a band around the earth at all points 90 degrees from the sublunar point, the horizontal or the tractive force of the moon's gravitation is zero, since the entire tide producing force is directed vertically inward. When the moon's gravity pulls at earth, the water doesn't float outward. It just gets pushed and squeezed around the globe, directed by both gravitational pull and other forces, until it ultimately ends up bulging out on the side closest to the moon and the side farthest away. About 70% of the Earth's surface is water. The Earth is rotating at about 1000 miles per hour, and at the same time it is moving around the sun at 63,000 miles per hour. The water surrounding the earth lags behind. This is due to inertia. See, water and air is not as rigid as the earth's surface, and it has the inertia to stay where it is. Here earth is the bike and water is you riding that bike. Now Earth is not accelerating and it is in a constant motion. And centrifugal force is making the water bulge out everywhere around the equatorial region. The tide raising forces of the moon that acts on the earth is about 9 millionth part of the gravitational force that is pulling the water towards the center of the earth. That is not enough even to lift a dry leaf 1 mm from the ground. Then how come the moon's gravity has any say on the tide? If I put things simply, the Earth's gravitational pull is enough to keep the water where it is. But near the equatorial region in the Earth-Moon line, the centrifugal forces is enough to bulge the water out. For simplicity's sake, let's keep the moon steady. The tidal force exerted by the moon is a composite of moon's gravitational attraction and a centrifugal force component created by the revolution of the Earth's center of mass around the center of mass of the Earth-Moon system. Remember Barycenter? Now there are a wide range of astronomical variables in the production of tides. How can I forget the sun? Though the effect of the sun's tide producing force is 46% that of the moon. This NASA animation shows how the sun, moon and various alignment with earth makes different kinds of tide. When sun, moon and earth aligns, the bulges get extra pull in the alignment line. This is called constructive interference. When the sun, earth and moon makes 90-degree angle, that is destructive interference. The bulge does not rotate with earth at the same speed. No sir. Actually, the water is very sluggish and earth actually rotates about 27 to 29 times inside this bulge of water before this bulge makes one complete rotation. But wait, there is more. Don't forget about 30% of the Earth's landmass is sticking out of the water. And that causes tidal movements clockwise or anti-clockwise with various frequency, that is time, and amplitude, that is height, depending on where you are looking. Water moves around like in a ball around these continents in approximately 12 hours. This rotation is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. And this is due to something called Coriolis effect. In the middle of the ocean, the amplitudes or the height of the tide is low and the amplitude is high at the continental boundary. This low point is called amphidromic point. So it is not like the water bulge washing over the landmass and moving from west to east. The landmass restricts the water movement. This NASA animation shows the frequency and amplitude of tides and their movements around the earth in 24-hour period. Even the depth of the water causes the tidal current to slow down. Narrow bays increase the amplitude of the tide like Bay of Fundy or Gulf of Khambat. Did you know that the tide don't always align perfectly with the moon? Earth rotates at a faster rate than the moon's orbital angular velocity. Moon is orbiting in the same direction as the earth rotates. It takes extra time for any point on our planet to rotate and end up exactly below the moon. This extra time is about 50 minutes. The delay in the response causes the tidal bulge to be carried forward. This means that the high tide bulges are never directly lined up with the moon, but a little ahead of it. And this is one of the reasons when the high spring tide happens earlier than the full moon or the new moon. Now tides are very complicated things and I have taken my liberty to omit something and simplify some other things. But I have tried to keep the topic to the very basics of how tide works. If you have any queries, you can ask in the comment below and I will try my best to answer them as per my own understanding. Thanks for staying till the end and keep learning and spread the knowledge.